In last lecture also, we have considered system matrix. We can say that any optical system is there and this is axis of symmetry. Then when the ray incident on it and before it enter into the system, the coordinates are lambda1 x1. And when ray emerge from the system, the coordinates are lambda2 x2. In between, these coordinates change due to the action of this optical system. And this action is represented by a matrix. It is known as a system matrix. So standard form of system matrix is represented by this form B minus A minus D and C. So if any optical system is given to you, our aim is to find this value B, a known constant, B minus A minus D and C, that is B, A, B, C, D. So the lambda1 x1 on which S matrix, that is our system matrix, operate and our emerging rays matrix is lambda2 x2. All the matrices have determinants value is equal to 1. So here the condition is this: determinant S is equal to BC minus AD and it is equal to 1. So with all this in mind, we can write all this important equation as T equal to 10 D upon N1 and 1 diffraction matrix is equal to 1 minus P0 and 1. System matrix is represented by B minus A minus D and C. તો આ બધા મેટ્રિક્સ આપણે બરાબર યાદ રાખવાના છે, ગમે ત્યારે આપણે યુઝ કરી શકીએ. So with all this in mind, now we are going to start the new topic. Today we are going to cover two topics. Number one, first we are going to find the relation between the object distance D1, image distance D2 and elements of system matrix. Elements of system matrix are A, B, C, D. So that we are going to find out, or we are going to derive in the first portion, and second portion we are going to find out the system matrix for a thick lens. તો બધી ઓપ્ટિકલ સિસ્ટમ આપણે એક પછી એક લઈશું અને એના સિસ્ટમ મેટ્રિક્સ શોધીશું અને એના પરથી આપણને ખબર પડે કે આ બધું શું ચાલી રહ્યું છે, ABCD કેવી રીતે શોધવાના, એને કેવી રીતે યુઝ કરવાનું, એ બધું હવે આપણે ધીમે ધીમે જઈશું. પણ આ બધા માટે આ રિલેશન ઇઝ વેરી ઇમ્પોર્ટન્ટ. So now we are going to start the theory. We have to consider, as usual, our optical system with axis of symmetry is in the Z direction. And let us place an object here, and this object is OP. Object distance is considered as minus D1. We know that for any optical system, all the left-hand side distances are considered as negative. So minus D1, object distance is considered as minus D1. And let us consider a ray started from P and it incident on the optical system at point Q. So this is one ray. This is our object. And from object, this is the top point of the object, this is the bottom point of object. And object is made up of thousands and thousands of points. So there is not only one ray started from the object. Such a thousands of rays started from the object, પણ આપણે 1000 ને બતાવી ના શકીએ, એટલે આપણે શું કરીએ છીએ, ખાલી એક જ રે, એક સમજવા માટે એક જ રે કન્સિડર કરીએ છીએ અને એ ટોપ પરથી કન્સિડર કરીએ છીએ. So this is a PQ ray. Initially, the coordinate at point P is represented by lambda1 x1. On this lambda1 x1, translation matrix operate and our coordinates or our matrix lambda1 x1 is changed into the new matrix, and that is lambda2 x2. On this lambda2 x2, system matrix operated, and when system matrix operated, this lambda2 x2 is changed into the new coordinate, and that is called lambda3 x3. So as it emerged from the system at that time, its coordinate are lambda3 x3 at R position. And now it formed the image. And this image at P dash, the coordinates are, images appear at D2 distance and coordinates are lambda 4, x4. So on lambda 3, x3, translation matrix operate and we get the top of the image. From top of the object or top of the object, we get the top of the image, which is called P dash. So this is how the process works. And D2 is the image distance and D1 is minus D1 is called the object distance. Now, refractive index of the medium, that is when we place the optical system in the medium of refractive index 1, that is air. So outside medium is considered as air. So we have to consider object OP at distance D1 and the image through the optical system is formed at position D2 and image is considered as O dash P dash. The ray emerging from every point of the object OP form the image O dash P dash on the other side of the optical system. And one of the such ray we have considered, and that ray started from point P and it formed the P dash point of the image. So we can say how the image formation takes place. So initially coordinates are lambda 1 x1. On lambda 1 x1, the translation matrix operate and we get lambda 2 x2. On lambda 2 x2, the system matrix operate and we get lambda 3 x3 matrix. On lambda 3 x3, second translation operator change it to the next matrix and last matrix it is lambda 4 x4. Where lambda 1 x1 is object matrix, lambda 4 x4 is the image matrix. And after series of procedure, how many procedure? 3. 2 translation and 1 system matrix, we get the image. The translation matrix is represented by this equation. T equal to 1, 0, D upon N and 1. Now let us consider here. Initial coordinates are lambda 1, x1. On that translation matrix operate. So what should be the value of the translation matrix here in this process when it converts lambda 1 x1 into lambda 2 x2? Can you identify it? Translation matrix T કેટલો આવે?
1.
1 ના હોય કોઈ દિવસ. મેટ્રિક્સ તો 2/2 હોય ને. 1 x1 છે એના ઉપર ટ્રાન્સલેશન મેટ્રિક્સ કયો છે આ, અને અહીંયા આગળ આપણે આ વેલ્યુઝ ચેન્જ કરવાના છે. પહેલું 1 0 તો એઝ ઇટ ઇઝ રહે, પણ ડી કેટલો છે આપણો? કેટલો છે ડી?
minus d1.
માઇનસ d1. અને n કેટલો છે?
1.
1. તો આપણે આ મેટ્રિક્સને કેવી રીતે લખી શકીએ? 1 0 minus d1 and 1. And at the end of the process, we get lambda 2x2. So we get lambda 2x2. Now next equation. Initial coordinate are lambda 2x2. આના પર કયો મેટ્રિક્સ ઓપરેટ કરે અને lambda 3x3 થાય? Which matrix is it?
System matrix.
શું નામ છે એની વેલ્યુ કઈ છે?
b minus a and minus dc.
minus a minus d and c ઓપરેટ થાય અને આપણા lambda 2x2 હવે શું થઈ ગયા? lambda 3x3. Now the next is lambda 3x3. On it કયો મેટ્રિક્સ ઓપરેટ થાય અને lambda 4x4 કરીએ થાય?
1 0 d2 1.
1 0 d2 and 1. It is translation matrix and at last we get lambda 4 XOR. તો ત્રણે ઇક્વેશન ને એક જ ઇક્વેશનમાં આપણે ફોર્મ કરવાનું છે. તો we have initially lambda 4 XOR is equal to 1 0 d2 and 1 and lambda 3 x3, but lambda 3 x3 is equal to b minus a minus d and c lambda 2 x2, but lambda 2 x2 is equal to 1 0 minus d1 and 1 lambda 1 x1. So substituting all these equations in this equation, we get this type of equation on which right hand side lambda 1 x1 is object matrix and left hand side we have image matrix. In between whatever the three matrix multiplication is there, it is called the system matrix. So this system, now it started from this point onwards and it end here. એની અંદર શું આવી ગયું? ઓબ્જેક્ટ ડિસ્ટન્સ પણ આવી ગયું, સિસ્ટમ મેટ્રિક્સ પણ આવી ગયો અને ઇમેજ ડિસ્ટન્સ પણ આવી ગયું. આપણે ખાલી ઇનપુટ આપવાનું છે ઓબ્જેક્ટ અને વી ગેટ ધ આઉટપુટ એઝ ઇમેજ. ખાલી આપણે ઓબ્જેક્ટની ખબર હોય તો આપણે ઇમેજ મેળવવા માટે શું જોઈએ? આટલું મેટ્રિક્સ આપણી જોડે છે. ધીસ ઇઝ અવર સિસ્ટમ મેટ્રિક્સ. આપણે ઇનપુટ આપવાનું ઓબ્જેક્ટ એન્ડ વી ગેટ ઇમેજ એઝ અ આઉટપુટ. So we can say that now we have to multiply, we have to find this system matrix. હવે આપણે આ સિસ્ટમનો મેટ્રિક્સ કે જેમાં ઇન્ક્લુઝન થાય છે ઓબ્જેક્ટ ડિસ્ટન્સ અને ઇમેજ ડિસ્ટન્સનું પણ વિથ સિસ્ટમ મેટ્રિક્સ. તો now we are going to multiply this matrix. હવે મલ્ટિપ્લિકેશન કોનું કરવાનું છે? આ ત્રણ મેટ્રિક્સનું કરવાનું છે. તો મેટ્રિક્સ મલ્ટિપ્લિકેશન કોઈ દિવસ પહેલા 2 થી સ્ટાર્ટ કરવાનું નહીં. આપણો સૌથી પહેલો પ્રોસેસ કયો છે? અહીંયાથી શરૂ થાય છે. પહેલું આવે આ ટ્રાન્સલેશન મેટ્રિક્સ 1, પછી આવે સિસ્ટમ મેટ્રિક્સ અને પછી આવે ટ્રાન્સલેશન મેટ્રિક્સ 2. તો ધીસ ઇઝ અવર ફર્સ્ટ મેટ્રિક્સ, ધીસ ઇઝ અવર સેકન્ડ મેટ્રિક્સ એન્ડ ધીસ ઇઝ અવર થર્ડ મેટ્રિક્સ. તો પ્રોસેસ જે રીતે થતો હોય એ જ રીતે મલ્ટિપ્લિકેશન કરવાનું એન્ડ ધેરફોર વી હેવ ટુ મલ્ટીપ્લાય ધીસ ટુ મેટ્રિક્સ ફર્સ્ટ. એ જે મેટ્રિક્સ આવે એના પછી આ બેનો એ મેટ્રિક્સ સાથે આનું મલ્ટિપ્લિકેશન કરવાનું છે. તો હવે આપણે સૌથી પહેલા આનું મલ્ટિપ્લિકેશન કરીએ. શું આવે? તો ફર્સ્ટ રો ફર્સ્ટ કોલમ, ફર્સ્ટ રો સેકન્ડ કોલમ, સેકન્ડ રો ફર્સ્ટ કોલમ એન્ડ સેકન્ડ રો સેકન્ડ કોલમ. આવી રીતે આપણે મેટ્રિક્સ મલ્ટિપ્લિકેશન કરવાનું છે. તો ફર્સ્ટ રો અને ફર્સ્ટ કોલમ શું આવે? ફર્સ્ટ એલિમેન્ટ
b plus a d1.
Very good. So 1 0 d2 1 and as it is rakhwano. First element is b plus a d1. First row second column. Second element is
minus a.
very good. Second row first column. Second row first column.
Minus d minus cd.
Minus cd 1. Minus d minus cd 1. And second row second column. શું આવે?
c.
So this is our matrix multiplication of these two matrices. And now we are going to multiply this with this. First row first column, first row second column, second row first column, second row second column. Multiply करो. હું થોડોક ટાઈમ આપું છું તમને. તમે લોકો બાયોલોજી વાળા છો એટલે તમને વાર લાગે છે, પણ આની તમે ઘણી પ્રેક્ટિસ કરવી પડશે. Got it? So lambda 4x4 is equal to, this is our answer. First element is b plus ad1, second is minus a, third element is b plus d1 into d2 minus d minus c d1, and the fourth element is minus ad2 plus c, and then lambda 1 x1. Now generally આપણે પહેલા નેગેટિવ ટર્મ લેતા નથી, એટલે આને આપણે ફરી રીઅરેન્જ કરીએ અને આ મલ્ટિપ્લિકેશનના આને સિમ્પ્લિફાય કરી દઈએ બ્રેકેટ કાઢીને. તો અવર simplified term is like this: b plus ad1 minus a, this is b into d2 plus a d1 d2 minus d and then minus c d1, and the positive term we are going to write first, so c minus ad2 and then lambda 1 x1. So our same equation is here, and now we rearrange this term in such a way that first element is a term first લખવાની, પછી b, પછી c અને પછી d. એવી રીતે આ ટર્મને આપણે ફરી પાછી લખી દઈએ. તો same matrix is same, but rearranging the term of third element, and we get this b plus d1 minus a d1 d2 plus b d2 minus c d1 minus d and then c minus a d2, and it is operated on lambda 1 x1, we get lambda 4 x4. So this is our matrix. We call this as equation number 1. That matrix operate on lambda 1 x1, we get lambda 4 x4. Now we further multiply first row and this first column, second row and this first column. So b plus ad1 is multiplied by lambda 1, minus a is multiplied by x1, so we get first element b plus ad1 into lambda 1 minus a x1, and similarly this first element is multiplied by lambda 1, and second plus second element is multiplied by x1. We get second element. So now we have on left hand side there is 2 by 1 matrix, on right hand side also there is 2 by 1 matrix, and we compare the first element with the first and second element with the second. So we get two equations. The first is equal to lambda 4 equal to b plus ad1 into lambda 1 minus ax1, and next equation is second element of RHS equal to second element of LHS, that is x4 is equal to a d1 d2 plus b d2 minus c d1 minus d into lambda 1 plus c minus a d2 into x1. We call this as equation 2 and equation 3. So two important equations we get from this comparing the 2 by 1 matrices. Now the equation 2 that we are going to use in next lecture. આ બરાબર યાદ રાખજો, આ equation ને આપણે હમણાં અડતા જ નથી, એને આપણે નોડલ પ્લેન નામનો ટોપિક આવશે ત્યારે એને યુઝ કરીશું, એટલે તમને ખ્યાલ રહે કે આ ક્યાંથી આવ્યું, એટલે અત્યારે મેં તમને રેફરન્સ આપી દીધો છે. તો આ equation આપણે પછી યુઝ કરશું. We are concentrating on equation number 3. So we can say that here, see, this is the object, and we consider this object made up of thousands of points, and for each and every point this equation is satisfied. આપણે હમણાં ખાલી એક રેફરન્સ માટે આ રે લીધું છે. આ ઓબ્જેક્ટ માંથી લાખો આવા રેઝ નીકળી અને ઇમેજમાં લાખો રે આવા પોઈન્ટ બનાવે અને ઇમેજ ફોર્મ થાય. So we can say that this equation holds true for each and every point of object and image. And therefore, we can say that now we consider axial point. Let us consider, are અત્યારે P ને બદલે આપણે હવે એ રેને અહીંયા ક્યાંથી લઈએ છે O પોઈન્ટ પર, એટલે કે એનો બોટમ પોઈન્ટ ઓફ ધ ઓબ્જેક્ટ. આ બોટમ પોઈન્ટ અહીંયા શું બનાવે તો અહીંયા પણ બોટમ પોઈન્ટ ઓફ ધ ઇમેજ ફોર્મ કરે. તો x1 is the axial point O અને x1 for axial point એટલે કે O પોઈન્ટ હોય તો x1 ની વેલ્યુ કેટલી થઈ જાય? હવે આપણું રે ક્યાંથી નીકળે છે? P પરથી નથી નીકળતું, પણ ક્યાંથી નીકળે છે? O પોઈન્ટ પરથી. અને ક્યાં જાય? હંમેશા O ડેશ પર જાય. તો એના માટે x1 ની વેલ્યુ કેટલી થાય?
0.
એક્સિયલ પોઈન્ટ માટે એ અહીંયા જ આવી ગયું અને એટલા માટે એક્સિયલ પોઈન્ટની વેલ્યુ કેટલી થઈ ગઈ? 0. તો આપણે કન્સિડર કરીએ કે x1 equal to 0, સિમિલરલી x4 equal to 0. તો આ ઇક્વેશન બધા જ પોઈન્ટ માટે જો ટ્રુ હોય તો આ એક્સિયલ પોઈન્ટ માટે પણ ટ્રુ છે. અને એટલા માટે આપણે અહીંયા અનનોન આ રિલેશન શોધવા માટે આપણે નોન વેલ્યુ સબસ્ટિટ્યુટ કરી. તો x1 equal to x4 equal to 0. તો અહીંયા 0 સબસ્ટિટ્યુટ કરીએ, અહીંયા પણ 0 સબસ્ટિટ્યુટ કરી દઈએ. તો now we can say that 0 is equal to a d1 d2 plus b d2 minus c d1 minus d into lambda 1 plus c into 0. c into 0 is equal to 0. And therefore, this whole bracket multiplied by lambda 1 is equal to 0. And therefore, this 0 is coming on the left hand side. Lambda 1 is coming on left hand side. So 0 upon lambda 1 is also equal to 0. And therefore, now we get the value of this bracket, and the value of this bracket a d1 d2 plus b d2 minus c d1 minus d, that bracket is equal to 0. And this is a very important relation. It relates how many quantities? See, it consists of a, b, c, d. It consists of d1. It consists of d2. So all the quantities are there, and if we substitute all this quantity, then its value must be 0. So this is the relation between the object distance d1, image distance d2, and the elements of system matrix A, B, C, and D, which is very, very important relation. જ્યારે પણ object distance, system matrix ને image distance ને આપણે લેવા હશે તો આપણે હંમેશા આ relation use કરવાનું છે. So now we substitute this equation 4 in equation 3. So equation 4 is substituted in equation 3. Then we have x4 equal to c minus ad2 into x1. અહીંયા આપણે એની વેલ્યુ મૂકી દીધી 0. So x4 is equal to c minus ad2 into x1. Or we can say that x4 upon x1 is equal to c minus ad2. And x4, according to this, we can say that it is height of image. And x1 is nothing but the height of object. So height of image divided by height of object is equal to, what is
Magnification.
Magnification. So that is called the m, and m is defined by height of image divided by height of object, and this magnification can also be obtained using the element c, image distance d2, and a, element of system matrix. So c minus ad2 equal to m, and that is our equation number 5. So for any optical system, magnification can also be found out using this equation. Now in equation 1, we can substitute this equation 4. So our matrix, system matrix, becomes very simple, and therefore it is b plus ad1 minus a 0, c minus ad2, and lambda 1 x1. So this is our object matrix, this is our image matrix, and then this is our system matrix. Determinant of each of this operator matrix must be 1. તો આપણને આનો પણ determinant 1 હોવો જ જોઈએ, એટલે કે આના determinantની વેલ્યુ શોધીએ તો આ બેનું મલ્ટિપ્લિકેશન માઇનસ આ બેનું મલ્ટિપ્લિકેશન, આ બેનું મલ્ટિપ્લિકેશન 0 થાય, and therefore સિસ્ટમ મેટ્રિક્સ આનો આ રહ્યો, અને આનો ડિટર્મિનન્ટની વેલ્યુ આપણે કન્સિડર કરીએ તો તો b plus ad1 into c minus ad2 અને minus 0 and that is equal to 1. એટલે કે b plus ad1 into c minus ad2 must be equal to 1. We call this as equation number 7. Now we already know that c minus ad2 is equal to magnification m. So we can substitute here m, and therefore substituting equation 5 in equation 7, b plus ad1 into m is equal to 1. So magnification can also be represented in another form. This is in the form of image distance, but now magnification m equal to 1 upon b plus ad1. If we know object distance, if we know a and b, we can find out the magnification. So all these equations, they are very, very important. We will use in next lecture magnifications equations. So now we can say that this magnification b plus ad1 is represented as 1 upon m minus a 0 and c minus ad2 is equal to m. So using this equation 5, this equation 8 in equation 6, our system matrix in the form of magnification can be represented as S equal to 1 upon m minus a 0 and m. So this is our equation 9, and this is about our theory. This theory is about the number 1 relation between the object distance, the image distance and the elements of system matrix. And after that we have find out the magnification. So this is about the theory. Now we are going to consider the next topic, and it is our system matrix for a thick lens. So we have to consider a very, very basic optical system, and that basic optical system is a thick lens. Let us consider this is our thick lens. The material from which we make this thick lens has refractive index n2. The thickness of the lens is T, and this is our axis of symmetry. Outside medium has refractive index n1 equal to 1. We place this lens in the air medium. The left hand side surface has radius of curvature r1, and right hand side surface has radius of curvature r2. So we have to consider a thick lens in which the medium of refractive index is n2, and it is enclosed by two curved surfaces with radius of curvature r1 and r2 with thickness t. The lens is placed in the air medium with refractive index 1. We want to find the action of this lens on the ray. એટલે કે આ system matrix of the lens we want to find out. So as the ray here incident, આ જગ્યાએ incident થાય છે, તો સૌથી પહેલા લેન્સ દ્વારા એના પર શું કરવામાં આવે, કયો કાર્ય કરવામાં આવે? બે જ ઓપરેશન છે આપણી પાસે. તો ફર્સ્ટ is which operation? લેન્સ દ્વારા સૌથી પહેલા શું થાય?
Refraction.
સૌથી પહેલા રિફ્રેક્શન થાય, કારણ કે જેવું અંદર એને અહીંયા ઇન્સિડન્ટ થાય અને સૌથી પહેલા એના પર સૌથી પહેલી જે ઓપરેશન થાય છે એ છે રિફ્રેક્શન. So before entering into the lens, the coordinates of the ray is λ1 x1, and the first refraction changed this λ1 x1 into the matrix λ2 x2. Now the ray started from P and it reaches Q point on the opposite side, and the coordinates are changed, and this change coordinate are λ3 x3. So now which operation changed this matrix λ2 x2 into λ3 x3?
Translation.
Refraction.
Translation in the medium of refractive n2 by how much distance? T on the axis of symmetry. And as it emerged, there is a lambda 3x3 converted into lambda 4x4. And the last operation is, કયું operation છે last?
Refraction.
Again, there is a refraction takes place. So we can say that the second operation is translation and the third operation is the second refraction on the matrix lambda 3x3 and it changed into the lambda 4x4. Where we already know that translation matrix operator is 1 0 d upon n1 1 and refraction matrix operator is equal to 1 minus p 0 and 1. So these three matrix operator we can write down as it like this. The first matrix operation પહેલું કયું છે તો refraction અને refraction matrix operation is represented by R1 કારણ કે બે refraction થાય છે એટલે પહેલા refraction ને આપણે R1 operator કહીએ and there is first P1 is the power of refraction of the first refraction. Power of first refraction 1 minus P1 0 and 1. Second operation કયું છે second operation?
Translation.
તો એનો ઓપરેટર શું થાય?
1 and 0 d upon n1.
1 0 પછી
d upon n and 1. Upon n 1.
કેટલું ડિસ્ટન્સ કવર કરે છે?
t upon n. t upon n.
T upon refractive index કેટલો છે?
1.
અંદર છે. Ray is inside. Inside the refractive index is n2. So 1 0 t upon n2 and 1. And the last matrix operator શું થાય?
Refraction.
ઓપરેટર બોલો.
1 minus p 0 1.
હા પણ હવે p ને આપણે બે ને જુદા પાડવા પડે ને તો 1 minus p2. P2 is the power of second refraction and 0 and 1. Where P1 and P2 is defined like this. P1 is equal to N2 minus N1 upon R. તો આપણા માટે P1 કેટલું છે? P1 કેટલો થાય આપણે આ refraction માટે? Refraction takes place at this position. N2 is the second medium.
N2 minus 1 upon R1.
Right. P1 is equal to N2 minus 1 upon R1. And P2 equal to P2 કેટલો થાય?
1 minus N2 upon R2.
Very good. કારણ કે refraction takes place here. For this refraction, this is second medium, this is first medium. So 1 minus N2 upon R2. It is equal to equation number 2. And now we can write down all this operation in equation form. So initial coordinates are lambda 1 x1. On it 1 minus p1 0 and 1 operated and we get lambda 2 x2. On lambda 2 x2 there is another translation operator 1 0 t upon n2 and 1 operated and we get lambda 3 x3. On lambda 3 x3 there is 1 minus p2 0 and 1 operated and we get lambda 4 x4. So substituting all this equation in the last equation, ultimately we get lambda 4 x4 equal to 1 minus p2 0 and 1, then 1 0 t upon n2 1 lambda 2 x2, but lambda 2 x2 is equal to 1 minus p1 0 and 1 lambda 1 x1. So this is the entering Ray matrix lambda 1 x1 and lambda 4 x4 is the emerging Ray matrix, and in between the three matrix multiplication gives us the system matrix of thick lengths. So if we multiply all the three matrix, we get the system matrix of these thick lengths. Now we are going to start multiplying the matrices. ક્યાંથી શરૂ કરવાનું આપણે મલ્ટિપ્લિકેશન?
પાછળથી.
P1 થી.
હા, છેલ્લા બેને મેટ્રિક્સનું મલ્ટિપ્લિકેશન કરવાનું છે. ચલો શરૂ કરી દો. ફર્સ્ટ રો ફર્સ્ટ કોલમ, ફર્સ્ટ રો સેકન્ડ કોલમ, સેકન્ડ રો ફર્સ્ટ કોલમ, સેકન્ડ રો સેકન્ડ કોલમ. હું થોડો ટાઈમ આપું છું તમને. So our matrix is like this: 1 minus P1 T upon N2 and minus P1 T upon N2 plus 1. Again we multiply these two matrices. First row, first column, first row, second column, second row, first column, and second row, second column. So this is our first row, first column. 1 is multiplied with 1, minus P2 is multiplied with T upon N2. So 1 minus T P2 upon N2. First row, second column. First row, second column. First element minus P1 is multiplied with 1, while second element minus P2 is multiplied with 1 minus T P1 upon N2. The second row, first column, 0 plus T upon N2, and second row, second column, that is 0, and this 1 minus T P1 upon N2, and ultimately we get this equation. So this is our equation. System matrix of thick length is represented by this equation, where generally we consider this positive term first, and we simplify this second term. So our equation is like this: 1 minus P2 T upon N2. Here the first term is minus P1, second term is minus minus plus, so P1 P2 T upon N2, and last term is minus P2 is multiplied by plus 1, so it is minus P2. The third element is remain as it is, T upon N2, and the last element is 1 minus T P1 upon N2, and then lambda 1 x1. So this is our system matrix of the thick length, and standard form of system matrix we know: B minus A minus D and C. So the first element is considered, if we compare it with this standard form, first element is this and it is B. Second element is minus A, so this element is equal to minus A. The third element is minus D, so T upon N2 is equal to minus D. And this last element is C, so this is equal to C. So system matrix of thick length is represented by equation 3, the same equation, and comparing with standard form. minus A is equal to minus P1 plus P2 into P1 T upon N2 minus P2. So if this is negative, if we multiply this equation by minus 1, we get the value of A, and A is now can be represented by P1 plus P2 minus P2 P1 T upon N2. This is our equation of A element. Now second element. What is the value of second element? B. What is B?
T upon N2.
One minus P2 T upon N2.
This is B. So B is our this element, and therefore B equal to 1 minus P2 T upon N2. What is the value of C?
1 minus P1 T upon N2.
And last is D. D equal to
T by N2.
T upon N2.
minus D equal to T upon N2, and therefore D equal to minus T upon N2. So these are the values of elements of the system matrix of thick lens A, B, C, D. Now we want to get the system matrix elements for thin lens. Thin lens means it is very thin, and in laboratory we are considering this type of thin lens. Thin lens means the thickness of the lens is very small compared to the radius of curvature of the lens. So if we consider such a thin lens, and for thin lens T is very small compared to the radii of curvature of its two refracting surfaces, then we can say that here T is very small and we consider T is nearly equal to 0. So in thin lens, we consider T equal to 0 in thick lens equations. So now our A is equal to P1 plus P2. So T equal to 0. B equal to, કેટલું થઈ જાય? B, C, D.
1.
C.
CA1.
D.
1.
0.
Minus 1.
Zero.
D કેટલું થાય? T equal to 0. બરાબર? So ABCD for thin lens is now readily we get from equation number 4 just by substituting T equal to 0. And these are the elements of system matrix of thin lens. So these are the equation number 5. And standard form of system matrix is equal to S equal to B minus A minus D and C. And in this also, this S is equal to આ સિસ્ટમ મેટ્રિક્સ થીક લેન્સનો છે, એના પરથી થીન લેન્સનો લાવવો હોય તો we substitute T equal to 0, then we get the first element B equal to 1, second element A is equal to minus P1 minus P2, third element is 0, and fourth element is equal to 1. So substituting T equal to 0 in equation number 3, we get this is the equation of system matrix of thin lens. એટલે આપણે લેબોરેટરીમાં જે યુઝ કરીએ છીએ એ નો સિસ્ટમ મેટ્રિક્સ આ ઇક્વેશન 6 પરથી આપણને મળી શકે. હવે આપણે યુઝ કરવાનું છે હંમેશા એ સિસ્ટમ મેટ્રિક્સની સામે ઓબ્જેક્ટ મૂકવામાં આવે તો જ આપણને ઇમેજ મળે, અને જ્યારે પણ ઓબ્જેક્ટ આવે એની સાથે આ રિલેશન આવે. This is the relation between the object distance d1, image distance d2 and elements of system matrix. આ છે આપણું ઇક્વેશન, આપણે હમણાં જ લઈ આવ્યા. આખા ઇક્વેશનને d1 d2 વડે ડિવાઈડ કરીએ. So if we divide d1 d2 આખું ઇક્વેશન, તો a d1 d2 આ દરેક ટર્મને d1 d2 વડે ડિવાઈડ કર્યા. 0 upon d1 d2 equal to 0 જ રહેવાના. So this is equal to 0. d1 d2 પહેલી ટર્મમાં કેન્સલ આઉટ, સેકન્ડ ટર્મ d2 is cancelled out, third term d1 is cancelled out, and now our equation is A plus B upon d1 minus C upon d2 minus D upon d1 d2 equal to 0. હવે જ્યાં આગળ આ A છે, B છે, C છે એની વેલ્યુ સબસ્ટિટ્યુટ કરીએ તો સબસ્ટિટ્યુટિંગ ઇક્વેશન 5 આપણા થીન લેન્સના સિસ્ટમ મેટ્રિક્સ એલિમેન્ટ્સ સબસ્ટિટ્યુટ કરીએ છીએ તો વી ગેટ P1 plus P2 is equal to 1 upon D1 minus 1 upon D2 minus D equal to 0 upon D1 D2. 0 upon D1 D2 is equal to 0. So this equation is equal to P1 plus P2 is equal to 1 upon D2 minus 1 upon D1. And 1 upon D2 minus 1 upon D1 is equal to 1 upon F. And therefore, this is the equation. P1 plus P2. P1 plus P2 બરાબર શું છે? A. And that is equal to 1 upon F. So our A element will lead us to the focal length of the optical system. So that is P1 plus P2 is also equal to 1 upon F and it is equal to A. We already know that what is the value of P1 in equation 1 and equation 2. P1 equal to N2 minus 1 upon R1 while P2 equal to 1 minus N2 upon R2. So we substitute that value here. So N2 minus 1 upon R1 plus 1 minus N2 upon R2 equal to 1 upon F. Or we can say that if we take this term, પહેલા N2 લખીએ પછી N1 લખીએ તો N2 minus 1 upon R1 minus N2 minus 1 upon R2, it is equal to 1 upon F. Here N2 minus 1 is common from both the terms. So taking N2 minus 1 common, we get 1 upon R1 minus 1 upon R2 equal to 1 upon F. And this is very well-known equation. Do you know which equation is this? N2 minus 1 into 1 upon R1.
Lensmaker equation.
Very good. So this equation is known as Lensmaker's equation for thin lens. So earlier you have derived this equation with a different approach. Using matrix method, we have also derived the same equation. So our system matrix of thin lens can be represented by this equation, where P1 plus P2 equal to 1 upon F equal to A. So thus we can say that our substituting equation 8 in equation 6, we get system matrix of thin lens and that value is equal to 1. P1 plus P2 equal to 1 upon F. So here we get 1 upon F, 0 and 1. So system matrix of any thin lens can be just obtained if we know the focal length. Focal length is known, we can find out the system matrix of thin lens. And see the determinant of each and every operator is equal to 1. So here determinant ની value જુઓ કેટલી છે?
1.
1 થયો ને? So this is 1 multiplied by 0. This is 1 minus 0, that is equal to 1. So this is about our theory, theory that we have discussed in today's lecture. First theory is about the relation between the object distance, image distance